Hey everybody, my name's Scott. I'm the CEO and co-founder of Sublayer, where we're building an AI agent framework that makes it possible to quickly build AI-powered automations or build your own custom AI-powered dev tools for for tedious, time-consuming, or like mundane, mind-numbing tasks that you might have to do. And make it easy to do that and make it cost effective to actually write automations for these things that were previously kind of much too, like maybe even too expensive to outsource even. And so like some of the benefits of writing these automations and writing your own dev tools can help you focus on actual innovation rather than doing mind-numbing repetitive tasks. And building them quickly, it enables rapid experimentation that previously a lot of these things for a very long, except for the last 3 years, a lot of these things that we're now able to do were previously like, you needed 6 developers to do. It took a couple years, maybe millions of dollars. A lot of these things are like a 10-cent API call away now. And a lot of us, even me, that have been working with AI for the last year and a half, have blinders on for some of these things that we can actually write software for, and it's cost effective to write software for. And some of the conversation that's been around that's been going around with AI writing software for us is that the costs are falling, and that opens up a whole new type of software that a lot of the time we have to make sure that the software lives a very long time to actually get our return on investment because it's so expensive. But if the cost falls enough, we might only need to use it once, and it changes a lot of the considerations when building software that you don't necessarily need to even worry about long-term maintenance. That I write it once, it takes me a week to write it, I run it, it fixes my problem in a week, and then I can throw it away, and I don't have to support it anymore. And so some of these real-world use cases that I'm talking about here are things like large-scale code transformations. Maybe you're doing a mass refactoring or a modernization going from one Java version to another, like Amazon talked about, or you're updating deprecated testing patterns, moving from one testing library to another, and you have thousands or tens of thousands of tests, and nobody wants to go through doing the mundane, like changing the testing library and the testing format. Or maybe you have like custom customer onboardings that your sales and solutions engineers know the steps that it takes to onboard a new customer, but each customer is different enough that you haven't been able to write like a solution that solves it for everybody. These AI automations, once you can build them very quickly, it becomes cost effective to actually do this. And especially for something like customer integrations, your customers are happy, they're using your product quicker, you're realizing revenue quicker. And then I think there've been a lot of demos out there for data analysis and reporting. You as developers have the ability to write these visualization helpers and these log analysis tools without putting a lot of work into it. And when you're done with them, throw them away. And so I am going to demo a little bit of our AI agent am I not connected? Our AI agent framework that, how many of you out there have either Googled or asked ChatGPT for how to generate a command line command for you? I know I have a lot. But while it gets it right, you have to open a browser, get out of your flow, copy and paste it back into what you were doing. But with our framework, one of the use cases that I've found really useful is actually building a command line tool to just generate it right in my terminal. So I'm going to walk through how to do that really quickly. So our framework has a new project creator. So we'll do sublayer new CLI helper. You can choose from a different template, different templates. We'll choose the CLI. You can select from any models, any model providers, or any of the models that they have. It creates the project for you. It sets up a Git repository, and then tells you the next step, which is change the directory. And then you can actually run the command, which we've set up an example command for you that you can use to check and make sure that it actually works. So we'll do bin CLI helper example. And it's a command that generates a story based on command line arguments. So we'll do a story about AI agent frameworks. And GPT-4o should hopefully, if the connection works, come up with a story about AI agent frameworks becoming the backbone of every industry. Sorry. And so another thing about this framework and how we've enabled it, or how we've made it possible to quickly build AI-powered DevTools, is that every component is designed to be generated by AI. And so to actually make the CLI helper work, we're going to use the layer. We're going to use our component generators to generate a generator. And what generators are in our framework are, it takes information from one or many sources and then sends it to an LLM and gives you structured data back in whatever format you ask for. And so what we're going to do is create a generator, give you a warning that we're actually going to use AI to generate this. And then the description for the generator is it will take a description of a task and generate a command line command to accomplish that task. Select the models again, and it's going to generate a generator, which we'll look at here. And so what this has done is created a subclass for the sublayer generators. It's generated a prompt for us to accomplish the task, and then also given us at the top here what we want to get back. We want to get the command line command back. And so let's copy this to generate command. We will give it a description of take a task description and generate a command line command. Usually Copilot jumps in here, but I guess I must be on a slow connection. This is command line generator, and it takes a task description. And then back here, we have the new command. And so this takes a task description, generates a command line command. So if we run it, what if we want to take a folder of JPEGs and create a GIF? Uses convert, delay 20, loop 0, folder of JPEGs. What if we want to use FFmpeg? And it's got a whole bunch of different flags here. And so this, I've actually built this in the past and have found it very useful. I've used it for even things like formatting header images for blog posts or social media. But for something like FFmpeg, there's a lot of these flags, and I don't, FFmpeg is going to do something bad to my system, but something you generate might. So if we wanted to maybe add a description, what we could do is create a new generator. And that takes a description of a task and generates a command line command to accomplish that task and a detailed description of what that command will do. Select the models again, generate a new generator, and it created a new command that's actually going to give us a different structure. Rather than just giving us a single string back, it's going to give us the command and the description. And we can go and wire that up and everything, but this is a very simplistic example. And something else that we've put together is to actually talk about what Naveen was talking about. I come from a group of weirdos that practice test-driven development. So there are dozens of us out there that like doing integration tests. But one of the things that I've put together, a much more complicated thing than that CLI generator that I put together, we have another component called an agent. And how you define an agent in our framework is by defining what triggers the agent, how the agent checks its status, what its goal is, what it's trying to do, and then how it steps toward that goal. And once you've defined those things, you can basically kind of let it loose and let it to do what it needs to do. And so for this TDD agent, we've set it up so that it gets triggered anytime an implementation file changes and a test file changes. The way it checks its status is by running the tests and examining the output. The goal is if the tests are passing. And the way that it steps toward that goal is by taking the implementation file contents, the test file contents, and the test output, sending it to an LLM, generates a new implementation, and then saves that file, runs the tests again, and keeps going. And so I've got an example here where we can testing agent pair on pile.rb and pile_spec.rb. The agent's going to run. The tests pass, so that it doesn't do anything. If we start modifying this, describe pile do, and the tests are going to run. It's going to fail because pile isn't defined, and then it creates the implementation to get those tests to pass. If we take it a step further and do describe add, it adds the item to the contents. Pile.new, pile.add apple, and then come on, Copilot. It's to include apple. And let's see, right? And so it sent the failing test, the test output, and generated the new implementation to get these tests to pass. And you can take this further, describe remove. It removes the item from the contents, and pile equals. And we can actually initialize it with something. So let's say apple and banana. We'll do pile.remove banana, and then expect that's not going to pass. There we go. And so it did it faster than I could actually finish writing this test. So what happened there is that I added this new remove test, or a new test for this remove function, and actually used a different initializer. It created an initializer that made both of those tests pass. It added the new remove method and made all those things pass. But this, since it runs on either side, it's actually self-healing. So if I go ahead and delete something here, it will run the tests again, and it actually made it pass in a different way. But so hopefully I guess I made it, give a couple examples on either end of the spectrum, something very simple that you can do, and then something kind of much further where you're integrating into system calls and your file system. But what we've found is that this is useful for everything on either end and everything in between for automating those tedious and annoying parts of the development process.